Hello, welcome back to another math video. Today we're going to continue taking a look at angles in standard position. Last video I left you with this question. I'm not going to label the whole triangle. Hopefully you whole angles. Hope you labeled yourself. Our focus here is to pick out the few special angles that we can use for reference. Okay, for reference. Remember, the terminal arm, the start of an angle, right, is always a positive x-axis. So this is the start. So where's 0 degrees? Well, 0 degrees start here and didn't go anywhere because angle is 0. So it's no angle at all. So the positive x-axis is actually 0 degrees. Okay, so 0 degree just looks like this. Start here and here. What about 90 degrees? Well, you start here and you rotate 90 degrees until you get perpendicular. That's what 90 degrees is. So 90 degrees will be here. Wait, that's just a positive y-axis, right? Positive y-axis. So 270 so 90 degrees, spoilers, 90 degrees is right here on the positive y-axis. All right, let's keep going. What about 180 degrees? 180 degrees is, well, a straight line, but also two 90 degrees together. So I rotate to 90, and I keep rotating 90 degrees more. Oh, this angle, as we did as an example before, in the middle of our example, that angle is positive 180 degrees. That's just the negative x-axis. So negative x-axis is 180 degrees. You probably see the pattern. Rotate 90 degrees more, we get 270 degrees. The last one is probably going to be the most interesting. And we rotate 90 degrees more, all the way around, full circle. If we rotate all the way around to full circle, like that, hey, we got 360 degrees again. Okay, well, not again, but 360 degrees. But it looks almost identical to 0 degrees. If we don't have that angle label there, we don't even know which one is which. Okay, the arms are identical. Okay, but one is reflexive. Okay, one is not. Okay, one is 0, one's acute. Okay, even though they look the same if we look at the arms. So that's why labeling the angles with that circle is very important. But since the arms are the same, right, that's really what makes an angle special. All right, perhaps 0 and 360, well, 0 cannot equal to 360 because they're different angles, but maybe 0 and 360 have some common properties. Okay, maybe it's congruent, you want to say, but that's not the best word. So there are some related properties between them. Okay, well, that is to come. That is to come when we look at our next concept. Okay, probably after we talk about it, you'll notice right away what 0 and 360 have in common. It's actually a very important thing they have in common. All right, as the opener, okay, I am going to pause this video. You're going to draw these three angles. Well, I'm going to draw these three angles, and then the key is you want to know which angle is the terminal arm in. Okay, the terminal arm. That's the important one. So the angle is in which quadrant? We mean the terminal arm. Okay, because all the angles start in the initial arm in the 0 degrees. That's not interesting. We want to know where the terminal arm ends. Okay, so give it a shot. Okay, pause the video and give it a shot. All right, I hope you actually paused the video and tried it. Let's just quickly do this one. We actually drew this one earlier together. The only one we didn't draw is that. Okay, now we're going to do that, or I'm going to leave that one out again. Actually, no, I think I'll do that one too. The first one is 90 plus 55, right? 90 plus 55, so it moves something more like that. Right, so that's 145 degrees. Okay, remember this part is 55 degrees. So it's in quadrant 1, 2, 3, 4. It's in quadrant 2. Okay, that's in quadrant 2. Do the same thing, 215. Initial arm Its reflex angle is somewhere over here. This little bit here is 35 degrees, but the whole angle is 215 degrees. Okay. Once again, you do not have to write down 35, but may be helpful. Okay, and you become even more helpful once we introduce the next concept. This one's in quadrant 3. Yes, you can use the Roman letters. I'm not that picky. Okay, I'm not that picky. Finally, 325 degrees. That's wow, you can even say, instead of thinking, you might think, what's 270? Remember, 270 degrees is down here. Okay, or 180 is here. 360 is here. So maybe instead of thinking 270 plus what give you 325, you can. Maybe it's easier. Well, let's draw the initial arm first. Maybe you can think of it's 360 minus some number because it's actually closer to 360. Looks like it's 360 minus 35, right? 35. Hey, wait, that number seems familiar. So it's 35 degrees here. Notice it's dotted. It's not the actual angle. The actual angle is right here. There is a reason I picked that angle though, but you'll see right away. So this is 325 degrees. Very, very big angle. Okay. And the terminal arm is in quadrant 4. Fine, I'll do this one in Roman. Just have some kind of symmetry. You know, the middle is written both ways. All right. So now here comes the interesting part. Okay. Remember, our goal in the end is to do trigonometry with these really complicated angles. And trigonometry originated from, let me bring out my highlighter, right angle triangles. Okay, so what we're going to do is create right angle triangles with these angles. How do we do that? Well, we do it by drawing a right angle triangle using the terminal arm and the x-axis. Terminal arm and the x-axis. Okay, I'm going to change color to green. Okay, what do I mean with terminal arm and x-axis? Well, here's my terminal arm, right? Maybe blue will stand out better, just realized. This is my terminal arm. Oh, that stand out more. Maybe just me. Terminal arm, this is the x-axis. I can form a right angle triangle just like that. Okay, there we go. All right, I'm gonna make my pen thinner. I'm gonna do the same thing. Now this is getting in my way, so I'm gonna write it smaller. I'm gonna raise 35 here. Okay. But remember, 35 was there for our own reference. Spoilers. You might not even know it, but it's actually a tease. And this angle here is 215 degrees. Okay, let's do the blue thing again. Terminal arm, x-axis, boom. There's my right angle triangle. Last thing, you can do it yourself. I'm not gonna pause the video and do that. I'm just gonna do it. Okay, I'm just gonna do it. Do it. Just do it. All right. Yes, I am a huge Star Wars fan. All right. Okay, I'm gonna need to write 35 somewhere else too. Okay. That angle here is 35 degrees. All right. Notice now we have a right angle triangle. We can actually do trig. But to do trig, we need a reference angle, right? We need something called a reference angle. Okay, I'm going to highlight that again. We need something called a reference angle. All right. What do you think is a good pick of the reference angle? I think it's pretty clear because our vertex are all here, right? So clearly the reference angle is with that vertex. Our reference angle would be the one inside. So this is my reference angle. I'm going to use the letter zeta r, right? Oh, wrong color. The reference angle is going to be that. That's my angle zeta r. This is my reference angle. Okay, maybe I should draw this triangle a lot bigger, which I will. Boom. Doesn't matter how big it is. Okay, doesn't change the question. 80 degrees. Okay, I'm not going to write 215. It's been there for a while. Hopefully you already drew it down. So the reference angle is right here. Ooh. Reference angle is right here. Zeta r. And reference angle is right here. Zeta r. Okay, now here comes the fun part. Here is the fun part. What are the reference angles for these three different angles? Okay, remember, three very different angles. This one's 145, this one's 215, this one's 325. They're all different angles. Okay, what are the reference angles? Well, this one is zeta r. The whole thing, remember the whole straight line here is 180. Whole straight line is 180. This portion is 145. Right? Or you can think of this whole thing is 90. This is 55. Regardless, I'm just going to go ahead. I'm going to take 180 minus my angle, right? It's a complement to my 145, right? The reference angle is complement to 145. So 180 minus 145, I got 35 degrees. Huh. Seems familiar. I will do the same thing again for this one. This one is not complement, however. Okay, to calculate this one, you got to be a little bit more creative. Okay, but maybe you don't need to. Remember, this angle is between the arm and the x-axis here. This whole thing is 215. This is just the extra part beyond 180, right? Just extra part. So the whole angle is 215. And zeta r is just the extra part. So it is minus 180 degrees. We got 35 degrees. Wait a second, 35 degrees. That's the same angle we used to help us draw. That's the same angle we used to help us draw. How weird. How weird. Some of you rolling your eyes, maybe behind the screen that I cannot see in the future. Watching this video and say, it's obvious. Anyhow, to the last one. You probably have no surprise. Why don't you use your logic and problem-solving skills, figure out how to calculate this reference angle, okay? Figure it out. But for this reference angle, despite the patterns, it's actually a 47. I'm just kidding. It's also 35. Isn't that cool? 3 different angles, okay? 3 different angles. They all have the same reference angle, okay? Same reference angle. What did you notice when I was drawing the reference angles? Okay, did I draw arrows for the reference angle? Besides the label of zeta r, besides labeling of zeta r, okay, did I draw any angles? Okay, does the direction matter? Okay, does the direction matter? What did I write? What do they have in common? At least based on our 3 examples, are they acute, obtuse, or are they reflexive? Right? What kind of angles are they? Or right angles, maybe. Okay. Well, right angles is not that special compared to the rest, but in that general, I mean, is it obtuse, acute, or reflexive? Those are more general. Okay. What are they? Well, think about it. Think about it a little bit, and we're going to summarize reference angles. All right. Hopefully you paused and thought about it a little bit. Okay. Let's take a look at what reference angles actually are. All right, reference angles is always drawn between the terminal arm and the x-axis, not the positive x-axis, just the x-axis as a whole. So between terminal arm, I'm going to write term arm because digital pen is not working so well. The terminal arm and the x-axis, not the positive x-axis, the initial arm, but the whole x-axis. Okay, the easiest way to know the easiest way to draw the reference angle is draw the right angle triangle first. So the terminal arm is right here. Right, the x-axis is right here. Here's my right angle triangle. A reference angle is always going to be the one inside the right angle triangle. That's my reference angle. Okay, that's the easiest way to draw it. Okay, but you don't have to draw the right angle triangle. This is just the easiest way. The reference angle is always positive. Okay, you might notice it's 35, 35, 35, not positive 35, negative 35, etc. Okay, so it's always positive, or rather, think of a science in science 10. Okay, it's magnitude only. It's not a vector. It's a scalar. Okay, it's scalar, or otherwise known as no sign or direction. Okay, it's just an indicator. It's like, oh, what's reference angle? 35. It's not positive 35 or negative 35. It just is 35. Okay, that sounds somewhat familiar. I guess I can say the same thing in a first semester for a different class. Okay, so it is not positive 35 or negative 35. The reference angle is just 35 degrees. Okay, it's no direction. It's just a scalar. Okay, because it's always between the x-axis and your terminal arm. Okay, the angle is always going to be an acute angle. Okay, your terminal angle is always going to be between 0 degrees and 90 degrees. Right? You can try it. Can you draw a reference angle with bigger than that? Remember, okay? If you draw it like this, this angle, you cannot form a right angle triangle with that angle. Right? It's impossible because it fits inside a right angle triangle. It fits in a right triangle, right? Remember, that's the goal. We want to develop an angle somehow for reference that fits into a right triangle, so we can later do some trig with it. Okay, so these are the 3 properties of reference angle. If ever need to find a reference angle, remember to check off these 3. All right, check off these 3. Here's an exercise, so you can draw the reference angle for this one. Okay, but we'll skip this one. We'll look at a little bit more. Now, knowing what a reference angle is all nice and dandy, but we should develop a way to calculate reference angles. Now look at our pictures. You probably have an idea, but I'm going to summarize it down here. Your terminal arm can be any of the 4 quadrants. Okay, most of them. Okay, special ones, they are special. Okay, now the general ones, they are either in quadrant 1, the terminal arm is over here. You'll notice the reference angle and the actual angle are the same. So the reference angle is actually, well, because the actual angle is already acute. So the reference angle is equal to your regular angle. If you're in quadrant 2, the right angle triangle is over here, but your actual angle is over here. Your actual angle is actually complement to a reference angle. So as we did before, your reference angle is actually 180 minus your actual angle. That will give you a reference angle in quadrant 2. In quadrant 3, do the same thing. Well, almost. It's because now your actual angle is in excess of your 180 degrees. It's the excess part that is your reference angle. So reference angle is equal to your actual angle. Subtract away 180 degrees to get the excess. Lastly, your reference angle is once again complete the full rotation of your reflexive angle. So reference angle is actually the entire 360 degrees minus your actual angle. Okay, so you can memorize how to calculate reference angle in each quadrant. This is a short way to do it. Or you can't remember how reference angle is drawn, then use geometry or geometry and reasoning or Cartesian reasoning, okay, to derive the reference angle formulas. Okay, these are not provided on any of the formula sheets because A, it is very easy to remember, and B, it is very easy to derive. Okay, once you understand the concept of a reference angle and of standard position. All right, and just as a quick exercise, we're going to do one example of 8 and 9 just for trial. Okay, draw an angle in standard position and determine the reference angle, 145 degrees. Okay, I think I could have done this already. We're not going to do that one. We're going to do 250 degrees. Okay, 250 degrees. Let's draw it. First, let's draw the initial arm, the easiest draw, and the vertex. 250 is a little bit bigger than 180. And what about 270? No, it's less than 270. So it's in quadrant 3. So it's going to be here somewhere. Probably closer to 270 than to 180 though. Probably here. All right, so this is my actual angle, 250 degrees. Now let us calculate the reference angle. Reference angle is, let's draw the right angle triangle. I'm going to be a lazy right angle triangle. Okay, it's my right angle triangle. My reference angle is here in red. It's in quadrant 3, so you can use the formula or you can use logic. Okay, so reference angle is our actual angle, 250 degrees, minus 180 degrees. Our reference angle is 70 degrees. Okay, 70 degrees. So you can write in 70 degrees. Remember, not positive 70, not negative 70. It's just 70. Okay, that's how you find and calculate the reference angle of any given angle. All right, next one. Okay, between 180 and 360, reference angle of 45. We want to determine the angle with its property. So the reference angle is 45. So remember, an angle has to be between 180 and 360. So it could be, try draw it yourself first. But 180 is here, 360 is here, so it's between there somewhere. So maybe it's that one. Of course, initial arm is here. Initial arm is always there. And the angle is that. Do we know its value? Not yet. But what we do know is the reference angle, terminal arm, and x-axis is 45 degrees, right? That's zeta r. Now, since it's in quadrant 4, using our logic, zeta r is equal to 360 degrees minus our actual angle. So if we rearrange, I'll skip some step rearranging, but the actual angle will be 360 minus the reference angle. So 360 degrees minus 45 degrees, which gives me, let's take a quick look, 615 degrees, I want to say. 200 and not 15. What am I talking about? Let's see. Give me 1 second. 315 degrees. There we go. Math is hard, and I'm teaching it. So our angle is actually equal to 315 degrees. All right. So that's my angle. Hey, hold on. I know. Wait. I hear across time that some of you yelling at the screen said, hey, I got a different triangle or a different reference angle. Like, why is that? Well, always says between 180 to 360, right? Why can't it be in quadrant 3? Of course it can be in quadrant 3. Okay, this is another one of those 2 answer questions, ambiguous case if you want. This question is actually ambiguous because, of course, you can have 2 answers. So that's quadrant 3 is the other one, of course. Oh, I forgot to label the angle, of course, again. So the angle is actually that one. That's zeta. So, all right. Now we're going to have to use screen to make sure it differs. The reference angle is here. Zeta r is 45 degrees. We do the same thing. We do the same thing, except this time it's very easy because zeta r is zeta minus 180 degrees. So zeta is just zeta r plus 180 degrees. So zeta is 45 degrees plus 180 degrees, which is, of course, 225 degrees. Okay? Just like our example, which reduced reference angles, these are 2 different angles with the same reference angle, okay, with the same reference angle. Okay, so there better be some intrinsic values that share between them trigonometry, because remember, reference angle came from right angle triangles, so these 2 share, if you want to think about it, they are in the same right angle triangle. Okay, the same right angle triangle. Let's think about what does that might imply about these 2 angles. Okay, they have same reference angle, even though they're different angles, they have same reference angle. All right, finally, wrapping up. Okay, wrapping up. The last concept I would like to introduce in this video is getting a little long, so this one is, I promise, going to be really short. It's concept of coterminal angles. Okay, coterminal angles. What do we mean? The good example is the one we have here. Draw 210. Okay, draw 210, and let's see. So let's draw 210. Boom, boom. Initial arm. 210 is just a little bit more than 180 right there. 210 degrees. 210 degrees. Use your creativity, use your imagination. Oh, I forgot to label it. 210. Okay. Use your imagination and creativity. Can you draw a positive and a negative angle in standard position, of course, but with the same terminal arm? Okay, same terminal arm. Okay, same terminal arm. I'm going to use different colors, of course. Okay, so what I mean is you cannot change the arm. You cannot change the arm. You can only draw location of the angles. The negative one might be obvious. Okay, take some time, think about it, be creative. Hopefully you tried yourself first already, but I can think of a negative one right away. That one. Right, that one. How much is that one? We might ask. Well, first it's negative. The whole thing adds up to 360. So this must be the other part of 360. So 360 minus 210. So this angle is actually negative. Let's do a quick calculation here. 150 degrees. So I found a negative one right away. So negative 150 have a same terminal arm as the 210. What about positive one? That might not be obvious on the first try. I do have to switch to thinner pen. Okay, well, one positive one I think of is, why stop there? Boom. I rotate a full 360. I rotate a full 360, right? 360, and then some. What is that? This angle is 360 degrees plus 210. Okay, which will give me, let's see, 570 degrees. Hey, that's another coterminal angle. Same terminal arm, coterminal. So any angle with the same terminal arm means they are coterminal. Do you think you found an equation to find all possible coterminal arms? Coterminal angles, I mean? Well, I'll give you a hint. You can rotate positively 1 360. You don't have to stop there. You can rotate 2 360s, 3 360s. You don't have to just rotate positive. You can rotate negative 360, right? You can rotate negative 360 and go like this, right? Negative 360, go all the way around, right? Negative 360. There's many ways, okay? Think about it, but if I write down the answer, it probably makes sense right away. It's 210 degrees plus 360 multiplied by a number n. N is a variable where n can be any integer. Positive 1, negative 1, positive 2, negative 2. So that's the general equation for all possible terminal arms. Coterminal angles, okay? We'll look at coterminal angles a lot deeper in Math 30, so that's why I want to introduce this, okay? But that's it. Oh, it's down here as well, all right? The only thing I want to say, the last thing is talking about coterminal angles, there's a concept called principal angles as well. Principal angle is the smallest positive coterminal angle, okay? Smallest positive terminal angle. You can try. For our example, of course, it's 210. Our EG here is 210. In general, principal angles is always between 0 and 360. All right, so we have finally developed the framework for doing trigonometry in. Okay, framework for doing trigonometry in. We've discussed angles in standard position in our last video. We've talked about reference angles and how reference angles can be the same for different angles. Okay, we talked about coterminal angles. We talked about how two different angles, right, 210 and 570 are different angles, how two different angles can even look the same unless we label it, okay? Look the same unless we label it. We're finally ready to do some trigonometry. But remember, there's a question motivated us to do this the whole time. 0 and 360 are very similar, right? Can you give me two things that are the same or describe the relationship between 0 and 360 degrees? Okay, I'll leave that as an exercise, okay, for you to think about. Coming back, we're ready to do some trigonometry, okay, and that's in the next video. All right, so think about the relationship between 0 degrees and 360 degrees. Okay, think about reference angles, think about coterminal angles. Okay, and next video, we're finally ready to do some trigonometry with this new angles introduced. And so with that, thank you for watching. I'll see you in the next video.